Okay, so this is where we kind of left off. So I just want to kind of finish up. I have like, 3 problems that I really would like to take the time to finish up. So for this one here, so this was this particular problem. So here is the what if scenario that we didn't get to. So that what if scenario is what if this was a picture of f prime of x? And then it's going to ask the same exact question. So what if this is a picture of f prime of x and not just f of x? So then the questions, okay, so I'm going to write this on the other side over here. So if that is f prime, then what would f prime of 2 equal? So what would that be? What about f prime of negative 1? So if this is now a picture of f prime graph, what would be f prime of 2 and what would be f prime of negative 1? Okay, so what are those? Okay, and then actually, you know what, let's go ahead and do f prime of 0 as well. We'll throw that one in as well. So for here, so what I have to remember is that this is a picture of f prime. So when I look at this coordinate here, this is my x value, right? So when x is equal to 2, what is this right here? So normally we would just say y, right? So that's x, that's y, but let's use the notation that we would normally use. So if this was just a regular f of x, this would be x, that would be f of x. But because it's f prime, then this is x equals 2, so this would be f prime of x, right? So with that said, what would be f prime of 2? So when x is 2, f prime of 2 would be 1. What about f prime of negative 1? So over here, so f prime of negative 1. So when x is negative 1, remember this is now my f prime value because it's a picture of f prime. So then f prime of negative 1 would be 1. So when x is 0, so that would be right here, this ordered pair, then f prime of 0 would be 0 as well. And that's because that ordered pair is 0, 0. Now, what if I had asked for like the second derivative? Like what is the derivative of this derivative at 0? That would be does not exist because of a sharp turn. But this is just asking for that corresponding y value, isn't it? It's not asking you to find a slope or a rate of change. It's just saying when x is 2, my y prime or f prime is just 1, right? So that's why this would still be 0. But if I had asked for what's the derivative at that point, so the derivative of the derivative, then that would be does not exist, a sharp turn, okay? All right, so there is that question. Okay, and then a couple others that I wanted to do. So is to kind of go back to that kind of velocity questions as well, just as a reminder of that. So if we have that our position function, and I asked for what is the velocity function. So that's when I take the derivative, right? So I would take the derivative of position to find velocity. And then I would do product rule, right? So I would do product rule for this one. So this would be equation 1 and equation 2. So I would do 1 and then d2, so the derivative of t is 1, and then the derivative of constant is 0. So 1 d2, and then plus 2, and then d1. So the derivative here is 2. Right, well it would be 2t to the 0, but t to the 0 is just 1, and then the derivative of constant is 0. So that would be velocity, and then acceleration. Let's go ahead and find acceleration next. So that would be when I take the derivative of velocity, which would be acceleration. So before I do that, I think I want to simplify, otherwise this is going to be kind of messy, right? So let me go ahead and simplify that a little bit first. So I'm going to scribble that out. just so I can take the derivative a little bit easier. So I would distribute the 1 in, so that would just be 2t minus 4, and then distribute in the 2. And then I would combine like terms. So 2t plus 2t is 4t, and then negative 4 plus 2 is negative 2. So there would be my velocity. Okay, so now let's go ahead and find that acceleration function. So now I'm going to go ahead and take that derivative. And so that would be a of t, right? Derivative velocity gives me acceleration. So there's an implied 1 here, so that would be 4 times 1, and then t to the 0, which is just 1, and then the derivative of a constant is 0. So the acceleration function would be constant, right? It would be 4. Okay, so then the second component to this question is, when is the particle at rest? So when is the particle at rest? And that would be when velocity is equal to 0. So I would set the velocity equation equal to 0, and then just solve that equation. So then that would be t equals 2/4 or 1/2. Okay. All right, and then now the next question is, when is the particle moving right? So when it is moving right is when it is greater than 0, right? So when is the velocity greater than 0? So there's two things to, try to do, to figure that out. I am just going to say, well, I know it's moving right when 4t minus 2 is greater than 0. So I can write it like that and then solve that equation. So I can add 2 over and then divide by 4. So that would be when t is greater than 1/2. So that's one way to do it, right? So I would just say t greater than 1/2. The other way to do it is, I know that I could do a sign analysis. So this is kind of a review off of last year as well. So a sign analysis, meaning, so this is velocity, that when t is equal to 1/2, that's when it's 0 or at rest. And so then if I were to pick any number to the left or to the right and substitute it into the velocity, so 4t minus 2, I can determine the sign of that. So pick a number bigger than 1/2, say 1, and if I plug it into here, that would give me 4 minus 2, which is positive 2. So that means anytime I pick a number bigger than 1/2, my velocity would always be positive, which is what we confirmed over here, right? So, or if I pick a number smaller than 1/2, say 0, and plug it in up here, I would get 0 minus 2, which is negative 2. So if I chose any number below 1/2, then I would get a negative number. And so that is another way to do it, right? To do the sign analysis, or you can just set up your inequality. Either way is good. And so then I would say it's moving right. Now if it said interval notation, then I would have to rewrite that, and I would say from 1/2 to positive infinity. Okay? And that would be how I do that. Okay, and so we'll call that good. So that's just a couple more practices I wanted to make sure that we got in. Okay?